The answer should be 145. Answer is 4. Answer should be 137. Answer should be 4. Answer should be 31. Pick a number from 1 to 10. The winning numbers today are 2 and 8. The homework check today is going to be the after-test assignment from Friday. If you were here on Friday and you don't have that paper here today, it is 100 million. For today, 9th grade patterns, functions, and algebra number 1, which would be the red cards. And we'll be on the red cards until at least Christmas, maybe a little after. After today, I can determine if a relation is a function or not. This is a function, and it is pronounced f of x, like this, f of x equals 2x plus 5. And what happens is you plug in numbers here, and you evaluate for an answer. You can replace f of x with y to make it into an equation. So you're going to plug in numbers for x and get back an answer for y. You plug in different numbers for x, you get back different answers for y. You'll have a table of values, essentially. So you're going to plug in whatever values you have here in for x, evaluate this part, and figure out what it's equal to, and put that beside it. On the left, all the answers that go in for, or all the numbers that go in for x are called the domain. All of the numbers that come out are the range. The in numbers are the domain, and the out numbers are the range. In terms of a pop machine, this will be the money that goes in. This is the can of pop that comes out. So if I plug in the numbers 1, 2, 3, and 4 into this function, I should get back the following numbers. If I put a 1 in here, 1 times 2 is 2, plus 5 is 7. So I put in a 1, and I got back a 7. That's generated an ordered pair of 1, 7. If I put in 2, I should get back a 9. 2 times 2 is 4. And then when you add 5, you come up with 9. If I put in 3, then I'll have 3 times 2 is 6, plus 5 is 11. If I put in 4, 4 times 2 is 8, plus 5 is 13. You have generated a set of ordered pairs. And this is what that set of ordered pairs would look like. 1, 7, 2, 9, 3, 11, and 4, 13. Don't forget that these are x, y points. The x number is first and the y number is second. This is what you put in, and this is what you got out in each case. For every domain element, there is exactly one range element. In terms of a pop machine, if I put $1 in the pop machine and press this button, I should get back a can of Pepsi. I should not be able to go back and put in $1, press the same button, and get back a can of Mountain Dew. Unless the guy loaded it wrong, which is not supposed to be the case. Every time you put a certain something in, you should get a certain something out. It should not change from time to time. If it does, it's not a function. If it stays the same, then it is a function. So that leads us to example number 1. You have a list of ordered pairs here. Look at the x values. 1, 6, 4, and 5. If all of those numbers are different, then the answer is yes. This is a function. if all of these x numbers are different? The answer is yes. For example number 2, look at the x numbers again. You have 1, 7, and then a 1. You have 2 1s in the x places. In this case, the 1 gives you a 6. But when you use 1 again another time, it gives you a 3. That's not the case. This, in other words, is a can of Pepsi, and this is a can of Mountain Dew. That's not a function. You can't get two different numbers from using the same x value. That would be a no. Try this problem and answer yes or no. On the practice problem,
Excuse me interrupting. We need sophomores G through Z to adjourn for picture, please.
On the practice problem, you have 7, 3, 4, and 8. They're all different, so the answer is yes. Bonus number 1. For the bonus problem, it should be 3x equals 13 plus 2. That's going to give you a 15, which you'll divide by 3 to get an answer of 5. Practice number 2. This one has 1, 6, 3, and 5. They're all different, so the answer is yes. Bonus number 2. Should be 3x or negative 3x equals negative 40 plus 7, which is a negative 33. Divide that by the negative 3 and get 11. Example problem number 3. You still have a domain and a range. These are the x values and the y values. This is what went in, this is what came out. For each domain element, you should only have one arrow leaving the number. So in this case, we only have one leaving the 2, one leaving the 3, one for the 7, one for the 9, and one for the 11. In that case, the answer is yes. And notice that you have 2 pointing to 12. You also have 11 pointing to 12. That is allowable. You can have two different domain elements pointing to the same number. That's not illegal because you still have just one number associated with each domain element. Example number 4. In this case, we have 1 that's leaving 1, but here at the 2, we have two things leaving the element 2. It's going to negative 3 and then also positive 3. That's not allowable. Therefore, the answer is no. That is not a function. Cannot have two lines leaving the same number and pointing to two different range elements. Practice problem number 3. For the practice problem, you only have one item leaving each one, so the answer is yes. Bonus number 3. You should have negative x equals negative 12 plus 9. That gives you a negative 3 on the right, but you must divide by negative 1, which makes that a positive 3. Practice problem number 4. On this one, you have just one leaving each domain element, so that is a yes. Bonus problem number 4. It should be 3x equals 8 plus 1, which will give you a 9. Divide it by 3 to get 3, and a phone call. It's time for the graduation test problem of the day. You're simply going to answer A, B, C, or D, and write your letters just like this. No lowercase stuff, no cursive stuff, capital letters only. 3 times x is 3x. 3 times a negative 6 is negative 18, and in this case it's minus 18. And 4 times x is 4x. 4 times a positive 7 is plus 28. It should be D. On this one, it should be 1 squared is 1 times 2 is 2 plus 3 is 5 plus 1 is 6 times 2 is 12 plus 3 is 15 plus 1 is 16.
84.